Okay, today we're talking about Chapter 2, Section 3, working with formulas. Okay, so we're going to go over a couple of formulas today that are pretty useful, and also just to really familiarize ourselves with formulas, how to use them and how to rearrange them and such. Okay, and let's see, pretty sure we're going to start off with an example about simple interest, but the interest formula being up here first, a simple interest I earned by investing money is equal to the product of the principal times the rate of interest R times the time in time t in years. Okay, so it's just going to be interest is going to be equal to principal times the rate times the time. Okay, and we'll just hit these one at a time. So let's go ahead and again hit example one. Actually, this is pretty good. Let's put that onto the front page as well. Okay, so what this reads is, if you know values for all but one variable in a formula, you can substitute those values and find the value of the unknown variable using the techniques for solving equations discussed earlier in this chapter. Okay, so that's very important because if you, what it says, right? If you know every variable, if you know the value of every single variable except for one, then it makes it pretty easy to be able to evaluate that particular variable, or yeah, that particular variable. And we'll see that in this example here. Okay. So our formula is I is equal to PRT. Okay, and again, this is just basically what this chart right here is saying. Well, circling in white does no good. What this chart right here says. Okay, so the problem down here, Maribel loaned 5,000 to a friend for 3 months at an annual interest rate of 8%. How much will her friend pay her at the end of the 3 months? Okay, so what we're going to do is we're going to we have our formula I is equal to PRT. We see that here. Okay, but instead, or not instead, but so what we're going to do first is we're going to write down what these are. I, P, R, T. Okay, so looking at the problem, Maribel loaned $5,000 to a friend. $5,000 will be the principal. Okay, to a friend for 3 months. 3 months is going to be the time at an annual interest rate of 8%, which is 0.08 if you write it in decimal form. We talked about that before. We want to find out how much will her friend pay her at the end of the 3 months. So, we don't know what the interest is, right? That's the unknown. So we're going to follow our formula here. I is equal to PRT. So we're going to say I, let's put it in green actually. So we're going to say I is equal to P, which is 5,000, times R, which is 0.08, times T, which is 3. Um, no, 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 no. I messed that up. I knew that the number would be way too high. So I messed that up because the time is 3 months, and 3 months is a quarter of the year. Okay, so uh, that's a very interesting way to mess up and to explain to you my screw up there, because I'm pretty sure some of you might do this as well. All right, so first of all, I knew that it was wrong because if I put a 3 in for t there, my number would be really large. Okay, and I know that that's not how money works. So in t in time years is t represents the time in years. Okay, well, 3 months is not even a year, is it? No, 3 months is a quarter of a year. So that's why I put 1/4 there. Okay, and that is how I know that how I knew that I had a problem there was because I did I did have a 3 here, and 3 times 5 is 15,000, and then 8% of 15,000 is a lot more than what she should expect to get after 3 months. But anyways, enough about that. Um, what is this? Well, we're going to have to do the math here. So put this into my handy dandy calculator. 5,000 times 0.08 times 0.25 is 100. Okay, so I said 0.25 because, well, you know that 1/4 is 25%. So after 3 months on a $5,000 loan, she's going to pay her friend back $100. That's an awful friend, making me pay interest on a friendly loan, right? So next up, we're going to have looks like okay. So we're just going to go from Celsius to Fahrenheit, and again, this is, and we'll talk about this here in a moment. We're going to go back to the very first page we had right here. So this is the formula to convert from Fahrenheit to Celsius. I know it's to convert from Fahrenheit to Celsius because we are solving for Celsius. Okay, so we're going to be using this formula for this problem. So given the formula, of course it gives us the formula, that's good. That's something we don't have to memorize. First find Celsius, if Fahrenheit is 212 degrees. Okay, so all we have to do is, so it says F is equal to 212. So all we have to do is plug in 212 for F. Okay, so let's write this out. So we've got C is equal to 5/9 times F. Okay, well F is 212, so 212 minus 32. Okay, and then notice how we have everything over here is just simply numbers. We just have to simply put this into the calculator, right? So 212 minus 32 is 180, and then 180 times 5/9 is going to be equal to 180 times 5/9 is equal to 100. And of course, we knew that because that's the boiling point. But anyways, so that's just going to be equal to 100. So 212 degrees Fahrenheit is just equal to 100 degrees Celsius. Okay, and real quickly before we do proceed, notice my notation here. I said C is equal to all this, which is now going to be equal to simply this. Okay, so I just do equal sign and then equal sign. Okay, it's just a little shorthand notation instead of saying, okay, you know, and writing independently C is equal to 100. And of course, there's nothing wrong with that, but in terms of, like, for me, for space on this board, that shorthand notation definitely helps. And secondly, we want to find and then find F when C is equal to 20 degrees. Okay, so this is interesting. So we need to find out what the Fahrenheit is when the Celsius is equal to 20. Okay, now there are a couple ways to go about this. We could, if we wanted to, simply put as 20 for C, and honestly, there's nothing wrong with this particular method. 20 for C is equal to F minus 32. We could do this and then proceed and solve for F, or we could remove the C there and just simply put a C, solve for F, and then plug C in. Okay, we're going to do it this way though, because like I said, there's nothing particularly wrong with this. So we end up with a 20 is equal to 5/9 F, and then 5/9 times 32, so 32 times 5/9 is 17 7/9. Let's see. I don't think there's anything wrong with that. Okay, so what we're doing here is let's actually do it the other way around. Right. Let's actually get rid of this 5/9 instead of distributing. So my first inclination was to distribute, but that we end up getting, you know, numbers, and I don't feel like dealing with numbers. So instead, what I'm going to do is I'm going to transfer this 5/9 from the right side to the left side here. Okay, so since we are dividing by, since we have a 5/9 on the right, in order to get rid of the 5/9, what I must do is I must multiply the right side by 9/5, and that cancels it, 9/5, and then multiply the left side by 9/5, like that. Okay. So we end up with 9/5 times 20. Well, 9 times 20 is 180. 180 divided by 5 is 36. So we end up with a 36 is equal to f minus 32. And if we solve for f, well, we add 32 to both sides, so we end up with 68. So 68 is equal to f. And so we went from Fahrenheit to Celsius and from Celsius to Fahrenheit. Okay, so this one, let's make this a tad larger. It's a lot of small notation there. Okay, so the lifting force F exerted on an airplane wing is found by multiplying some constant k by the area A of the wing surface and by the square of the plane's velocity. So our formula is going to be F is equal to k, some constant k, right, times A, which is area, times V squared, which is the velocity. So we need to find the force on a plane's wing during takeoff if the area of the wing is 120 feet squared, k is 4/3, and the plane is traveling 80 miles per hour during takeoff. Okay. Well, in this particular case, we're looking for F. So let's write this. So F is equal to, we don't know. K, right, we're told K is equal to 4/3. A, we are told, is equal to, what is it? 80. So 80 miles per hour. And I'm sorry, that's not it. Is equal to 120. That's the area. I was thinking acceleration. So A is equal to the area, and then V would be 80. So V is equal to 80. Okay. So in my formula, all I have to do is plug in those values. Right. Well, my formula was F is equal to KAV squared. Okay. Well, I don't know what F is, but I do know K is equal to 4/3. So we're going to erase K and put in a 4/3. My area is 120, so I'm going to erase the A and put in a 120. I'm going to run out of room there, so I'm just going to do this. So 120. And then my velocity is 80, and remember, velocity is squared, right? That's what we see here, right here. Velocity is squared. And so at this point, we just have to plug all this into our calculator. So it's 4/3 times 120 times 80 squared. 80 squared, which is equal to, what is a big number? 1024,000. Okay, so the force on the plane's wing during takeoff is 1,024. What does it tell us what it is? Well, it would be feet or per pound, right? So it'd be pounds. So the force is 1,024 pounds. Right. More formulas. So the perimeter of a triangle is 38 feet. One side is 5 feet long and the second side is 18 feet long. How long is the third side? Okay, so let's go back. Let's see if we have us our triangle formula here. Yep, no, that's the perimeter of a rectangle. There it is. Okay, so the perimeter of a triangle is down here. The perimeter of a triangle is just equal to the three sides, right? The perimeter, and of course that's going to be the case, and which makes sense, and I'll draw it out here in a moment. But the perimeter is just simply A plus B plus C, where A, B, and C are sides of a triangle. And I said, well, that makes sense because, let's imagine we have as a triangle. Okay, and again, the perimeter is just basically this side plus this side plus this side, which makes tons of sense. That's a formula that you could derive on your own. Right? So the perimeter of a triangle is 38 feet. So 38 feet is the perimeter of a triangle. And again, it was A plus B plus C. One side is 5 feet long. The second side is 18 feet long. How long is the third side? Okay, so the third side, which we put as X. Right? Well, we know that the left side is equal to 38, and we must equal 38 on the right side. Okay, so we could do that kind of math in our head, but for the sake of it, let's just go ahead and do this where we subtract, numbers and all that good stuff like we have done before. Okay, so let's go ahead and combine like terms. 5 and 18, that's 23. 23 plus x. And then we have to isolate the x by itself, so we're going to subtract 23 from both sides. and we end up with a 15 is equal to x. Okay. And that's that. All right, so this is solving formula for different variables. All right, this is a very important technique that honestly you're gonna need to master, especially going forward in your college courses. But it's not hard. And honestly, in my opinion, I think it's easier doing this than actually moving numbers around. And the reason why is because let's just jump straight down here to d is equal to rt. If I want to solve for t, okay, so in this particular, oh, that was the example. Okay, so let's actually do the example. I didn't mean to snip that far down, but here we are. So in the example, given d is equal to rt, so that's distance equals rate times time, solve for t. Well, I guess I don't have to put it over there because it's going to show it. But anyways, we want to represent the time in terms of distance and rate. So we just want to solve for t. So if we have d is equal to rt, right, we want to solve for t, well, we divide both sides by r. And that's it. We just divide both sides by r, and we get d over r is equal to t. All right, I think that's pretty easy. Let's go to example 6, and certainly that would be a little bit tougher. Maybe not. It looks pretty short. Okay, so example 6, given v is equal to k over p, we need to solve for p. Okay, and it says in terms of v and k, so but basically we need to solve for p, right? So we have the formula v is equal to k over p, and we need to solve for p. So how do we solve for p? Well, we need to get it by itself. Okay. Well, first thing I need to do, it appears since p is in the denominator here, is I need to multiply both sides by p. So if I multiply this side by p, well, that cancels, right? And if I multiply this side by p, I end up with PV is equal to K. Well, I need to divide both sides by V to get rid of the V over here on the side where the P is. So I end up with a P is equal to K over V. And that's it. And like I said, I think this is a lot easier than actually solving this with numbers involved, but that was it. And so the reason why I skipped over the second method, if you recall, I was talking about the Fahrenheit and Celsius, because I had remembered that we're going to be talking about actually changing it from one to the other. So I stopped, and this is why. So this reads, given that c is equal to 5/9 times f minus 32 as an example 2, solve for f in terms of c. Okay, so and of course this would give a formula for finding Fahrenheit temperature given in Celsius temperature values. So we need to solve for f. So we've got c is equal to 5/9 times f minus 32. Okay, we need to solve for f. So how do we solve for f? Well, we need to first isolate. F. So how would we go about isolating f? Well, we can kind of do the same thing we did before, right? So what we're going to do is we're going to multiply both sides by 9/5, and let's move this over to the right just a tad. Okay, so we're going to multiply both sides by 9/5. So 9/5 on the right side, right? This cancels with this, and this cancels with this. Perfect. And then we multiply 9/5 on the left side, so we end up with 9/5 c. Okay, so we have 9/5 c is equal to f minus 32, and then we add 32 to both sides, so we simply have 9/5 c plus 32, and that's equal to f. And that's it. we just simply solve for Fahrenheit. So, and of course we like to have things on the left side, so let's go ahead and put f as equal to 9/5 plus 32. And there's actually another formula where you add 40 multiply by 1.8 and then subtract 40 multiply by 1.8. I think it's an easier formula, but we're just going to stick with this for now. All right, so solving for different variables. So given the equation 2x plus 4y is equal to 10, we need to A, solve for x in terms of y, and then B, solve for y in terms of x. So what we're going to do is we're going to just simply rearrange things and solve for each individual variable, which again, this is good practice for what we do later on, uh, whether in this particular course or the next. So if we want to solve for x, right, so let's start off like this, 2x plus 4y is equal to 10. We want to solve for x, so the first thing we need to do, let's go ahead and subtract both sides by 4y. Right? So if we subtract 4y here, and we subtract 4y here, right, they are not like terms, so I can't just take it from the 10. I end up with a 2x is equal to 10 minus 4y. Okay. Well, next up, I need to divide both sides by 2 now, right, because I need to isolate the x. So if I divide both sides by 2, divide by 2 here, the 2's cancel, and then I divide by 2 on both of these. Okay, I can divide by 2 on both of them and put it under here, which I'm not going to say it makes it more complicated, but I think it is okay, but it doesn't make it as easy to compute as if I would have done this. Right? That makes it a lot easier to compute, doesn't it? Okay. Well, the x on the left side just simply stays because the 2's canceled, and then over here we have 10 over 2, which is a 5, minus, and then 4y over 2, that's just going to be a 2y. Okay, and let's go ahead and snip this and do it again on the next page since I ran out of room for B. Okay, so B, we want to now solve 2x plus 4y is equal to 10. Now we want to solve for y. Okay, so now we want to subtract 2. Did I do that? Okay, yeah, sorry. Okay, so now we want to solve for y, so we're going to subtract 2x on both sides, so minus 2x here, and that cancels that, and then a minus 2x over here. So we end up with a 4y is equal to a 10 minus 2x. And the same thing, we're going to divide both sides by 4. Okay, and again, you can do this, and there's nothing wrong with it. Okay, but I do believe, as I mentioned on the previous page, I think it's just easier to do this. Just put it everywhere, right? Well, 4y over 4, well, that's canceled, so that ends up with a y, which is exactly what we want. 10 over 4 reduces down to 5 halves, and then minus, well, 2 over 4 condenses down to 1 half x. Okay, or we could also write that as 5 halves minus x over 2. Okay, so notice how I could write this as negative 1 half or x over 2, right? I can move the x from the numerator off to down here to the right, or move it up into the numerator. Okay, and I believe that does conclude today's lecture.